They're part of an ancient quest to push beyond our boundaries, to see what lies beyond the horizon. Now, tens of billions of kilometers from Earth, two spacecraft are streaking out into the void. What will we learn about the galaxy, the universe, and ourselves from Voyager's epic journey to the stars? December 19th, 1972. The splashdown of the Apollo 17 crew capsule marked the end of the golden age of manned spaceflight. The Mercury, Gemini, and Apollo programs had proven that we could send people into space. To orbit the Earth. Fly out beyond our planet. Then land on the Moon and walk among its ancient craters. The collective will to send people beyond our planet faded in times of economic uncertainty, war, and shifting priorities. And yet, just 5 years after Apollo ended, scientists launched a new vision that was just as profound and even more far-reaching.
We knew we were on a journey of discovery when we launched the Voyager spacecraft, but we had no idea how much there was to discover.
We had a sense that we knew what it felt like to be Magellan or Columbus.
It didn't all go smoothly. Early computer problems threatened to doom Voyager 2. Then its radio receiver failed, forcing engineers to use a backup. Now, after more than 3.5 decades of successful operations, the twin spacecraft are sending back information on their flight into interstellar space. Along the way, they have revealed a solar system rich beyond our imagining.
Time after time, we're surprised by seeing things that we had not expected or even imagined. Volcanoes erupting from a moon Io. The possibility of a liquid water ocean under the icy crust of Europa. Titan, where we found an atmosphere. Uranus, small moon Miranda, which had one of the most complex geologic surfaces we've seen. Even at Neptune, Triton, 40 degrees above absolute zero, even there were geysers erupting.
It's the only spacecraft that's gone by Uranus. It's the only spacecraft that's gone by Neptune. Everything we know about those planets, we know from Voyager.
To see those first pictures coming in from the outer solar system, for the first time, what had been a point of light in the sky was a place.
The journey was made possible by a rare alignment of the planets, a configuration that occurs only once every 176 years. That enabled the craft to go from planet to planet, accelerating as they entered the gravitational field of one, then flying out to the next. The Voyagers carried a battery of scientific equipment to collect data on the unknown worlds in their path. That included a pair of Vidicom cameras and a data transfer rate slower than a dial-up modem. They are primitive by today's standards, but that didn't stop them from returning a flurry of discoveries. On Jupiter's moon Io, Voyager's cameras spotted 9 erupting volcanoes. They documented volcanic plumes reaching 300 kilometers into the atmosphere at velocities of 1 kilometer every second. Almost 2 years later, on November 12, 1980, Voyager 1 sailed down to within 124,000 kilometers of Saturn's cloud tops. That's 1/3 the distance between the Earth and the Moon. It found that Saturn's atmosphere is almost entirely hydrogen and helium. It is the only planet in our solar system that is less dense than water. 1 year earlier, Pioneer 11 had detected a thick gaseous atmosphere on Saturn's large moon, Titan. Scientists decided to send Voyager 1 to follow up. It sent back clues to one of the most fascinating bodies in the solar system. Titan proved to be the only object in the solar system, other than Earth, with stable bodies of surface liquid. Not water, but vast lakes of liquid methane. Scientists could have chosen to send Voyager 1 out to Pluto, but Titan was more promising scientifically. But that meant its grand tour of the outer planets was over. Voyager 1 headed north, above the plane of the solar system. 5 years later, and over 1.5 billion kilometers beyond Saturn, Voyager 2 reached Uranus. Like all the other planets, Uranus spins like a top. But Voyager 2 found that it's actually tipped on its side. Its magnetic field reaches out in a bizarre corkscrew tail, millions of kilometers into space. Voyager 2 discovered 2 new rings, thin, dark bands of ice, rock, and dust, with particles the size of a fist. Although the craft discovered 10 new Uranian moons, the most eagerly anticipated event was a close encounter with Miranda, perhaps the most bizarre object in our solar system. Close-ups revealed a strange and wondrous landscape, including a canyon 19 kilometers deep. Miranda may have collided with another moon, shattered, and then, by the force of its own gravity, slowly reassembled into this chunk of rock and ice. After 12 years on the road, Voyager 2 now sped toward its rendezvous with Neptune. The planet appears blue because methane in its atmosphere absorbs most of the red in the light spectrum. Remarkably, Voyager 2 flew by Neptune only 35 kilometers off its chartered course and only 1 second off its scheduled flyby time. Skimming over 5,000 kilometers above the planet's north pole, Voyager found Neptune to be a giant ball of melted rock and ice. Cloaked in hydrogen, helium, and methane gases, its atmosphere is whipped by winds of 1,000 kilometers per hour. Flying in closer than any spacecraft has come to one of the outer planets, Voyager 2 discovered at least 4 complete rings of ice and rock, 6 new moons, and a great dark spot, a hurricane the size of Earth, raging in Neptune's southern hemisphere. The storm circles the planet every 18 hours and rotates around its own axis every 16 days. Oddly, the largest of Neptune's 8 moons, Triton, orbits in the opposite direction to the planet's spin. Triton was likely an independent object in orbit around the Sun until it was captured by Neptune's gravity. Pocked with impact craters and glazed with methane and nitrogen ice, Triton is the coldest known object in the solar system, at minus 240 degrees Celsius. On its surface, scientists saw jagged mountains, high cliffs, and frozen lakes. The most bizarre discovery was the presence of icy geysers with plumes reaching 160 kilometers downwind. Leaving Neptune, Voyager 2 snapped one of the most remarkable pictures ever taken. Neptune and its cold moon Triton, framed by the dim light of the Sun. Several years earlier, the Pioneer spacecraft carried a plaque illustrating the spin state of a hydrogen atom, a man and woman set against an outline of the spacecraft, and the position of the Sun relative to 14 prominent pulsars. The Voyagers brought their own message in a bottle, a disk encoded with images of life on Earth, greetings in 55 languages, a selection of music, messages, and natural sounds.
And here was this Noah's Ark of human culture that was being sent to the outer planets and then beyond to wander in the interstellar darkness for 1 billion years. On Valentine's Day, 1990, Voyager 1 looked homeward, and what did it find? Not the frame-filling Apollo Earth, but instead that 1 pixel Earth. That's here. That's home.
13 years after launch, in the year 1990, the Voyager craft finally began their journey into the galaxy at large. They run on plutonium-powered radioisotope thermoelectric generators, a standard setup for NASA deep space missions. Because even these systems don't last forever, scientists have had to shut down Voyager's instruments one by one. Among the most valuable remaining sensors are magnetometers that can read magnetic fields that constantly sculpt the outer solar system. This region is the outer edge of a bubble formed by the Sun's magnetic field and the solar wind.
Tonight we're going to be getting the data back from a magnetometer roll calibration maneuver. And that maneuver actually happened on the Voyager 1 spacecraft more than 16 hours ago, but the data is finally making it back to the Earth. What we're doing is a roll about this high gain antenna. And so if the high gain antenna here is pointed out toward the Earth, we're going to be rolling the spacecraft along that high gain antenna. That roll is done so that we can calibrate the instrument so that we know what magnetic field belongs to the Sun and what component belongs to the actual spacecraft.
They're very near the edge of the bubble the Sun creates around itself, called the heliosphere. We're getting very close to the boundary. We don't know how close because no spacecraft has ever been there before. But it could be another few months, it could be another few years, but it's probably not much longer than that. We travel 1 billion miles every 3 years. You can't see the bubble the Sun creates around itself because it's invisible, but we can see an analog of it in a sink. If we turn the water on very fast and look at the bottom of the sink, we see that near where the water hits the bottom of the sink, it's flowing very fast radially outward in all directions and getting thinner until it abruptly slows down in this thick region and turns around and flows down the drain. The two Voyager spacecraft are both in this thick region in our heliosphere where the wind has slowed down and is turning to go down the tail of the heliosphere. And eventually, within, we hope in not too many more years, Voyager 1 will leave this thick region and enter interstellar space. We have a 20-watt transmitter on the spacecraft transmitting over 11 billion miles away. And so it comes in very slowly, but every bit left that spacecraft over 16 hours ago. Every bit is telling us something new that we haven't known before.
As the solar wind travels out from the sun, it pushes against the galactic medium and abruptly slows down in a region called the termination shock. Outside this is the heliosheath, where the sun's magnetic field is bent back by the interstellar wind. The sun's magnetic field spins in opposite directions on the north and south poles, creating a sheet where the two spins meet. This sheet gently ripples as it travels outward. When this sheet reaches the termination shock, it starts to compress like water waves hitting a wall. The Voyager spacecraft have now found that these stacked up ripples of magnetic field form smaller bubbles, shown here as a computer simulation. The discovery of this frothy character changes our understanding of how extremely fast-moving particles, called cosmic rays, enter our solar system. When they arrive at this region, they slowly move from bubble to bubble until they can reach smooth magnetic field lines and follow them toward the sun. Recently, the twin Voyagers began their transition into interstellar space.
Voyager today is headed for the edge of interstellar space. That's the space between stars, and it's filled with material that has been injected by the explosion of stars, matter which came from a particular direction, creating a wind which has shaped the bubble in which the solar system is surrounded.
Since July of 2012, the solar wind has decreased, while the galactic wind has sped up. That places the craft in what scientists call the magnetic highway, where the alignment of magnetic fields allows particles from the sun to escape and particles from the galaxy to pour in. When either one reports a complete change in the direction of the magnetic field, that's when scientists will know that it has finally exited the solar system. Meanwhile, they're delivering a whole new view of the galaxy in ultraviolet light. From Earth, this light is normally blocked by the haze of particles at the edge of the solar system. Scientists are able to capture this light from other galaxies because their wavelength has been shifted slightly by their journey through space. Because ultraviolet light reveals the location of vigorous starbirth, it is providing a new window on the evolution of our galaxy. The Voyagers will keep sending back this and other valuable data sets until their power begins to run out. They'll finally go dead around the year 2025. Voyager 2 will be heading south toward the constellation Sagittarius. Traveling at 16 kilometers per second, it is expected to pass 4 light-years from Sirius, the brightest star in the heavens, 290,000 years from now. Its twin will continue on a northward track to a relatively empty region of our solar neighborhood. They will become silent emissaries from planet Earth, symbols of our boundless curiosity and aspiration. In the words of Carl Sagan, "These spacecraft have taught us about the wonders of other worlds. About the uniqueness and fragility of our own. About beginnings and ends. They have given us access to most of the solar system, both in extent and in mass. They are the ships that first explored what may be homelands of our remote descendants. At the same time, Voyager's journey into the vast and forbidding oceans of interstellar space reminds us how closely our fate is tied to our home planet. The twin craft will wander the galaxy undisturbed for millions, even billions of years. They will endure long after everything else man has built has crumbled to dust. Compared to Voyager, we are living on borrowed time. For mammalian species only lasts on average about 1 million years. Our ability to follow them into deep space will take a new perspective on time and distance, beyond the short years and decades of human activities. We'll continue to track Voyager's slow but remarkable journey, while our civilizations and our planet change and evolve in the cosmic blink of an eye.